We're moving on to lesson 2 for pre-college algebra. This is actually section 1.7. We're going to talk about simplifying algebraic expressions, and we're going to talk about some of the properties that we can use with numbers and expressions. The first property that we're going to look at is the commutative property. When you think about the word commutative, you could think about your commute to work, right? You're moving from one place to another. The commutative property is exactly that. It means that you can commute items. You can move items with no problem. Now, the commutative property applies to addition and multiplication. It does not apply to subtraction, division, and exponents. Another example, when you're getting dressed, it doesn't matter whether you put on your left sock or your right sock first. You're going to end up with both socks on. So the commutative property, it means it doesn't matter which item you add or which item you multiply first. Multiplication and addition are commutative. Some examples. If we did 5 plus 8 and 8 plus 5, we commuted the items. We changed the order of the items. 5 plus 8 is 13. 8 plus 5 is 13. Addition is commutative. 5 times 8, 8 times 5. 5 times 8 is 40. 8 times 5 is 40. Check. Multiplication is commutative. We can change the order. 5 minus 8, 8 minus 5. Subtraction is not commutative. 5 divided by 8 and 8 divided by 5, if you type those in the calculator, you get two decimals that are not the same. And so division is not commutative. With multiplication and addition, you can change the order of the items. The associative property is the next property we're going to talk about. If we think about the word associate, that means people that you are in a group with, right? So the associative property dictates the manner in which you can group things. Again, addition and multiplication are associative. So we can, with addition, associate the 5, 10. If we have 3 or more items, right? 5, 10, and the 2, we can associate the 5 and the 10 together, or we can associate the 10 and the 2 together. With multiplication, we can associate the 5 and the 10, or the 10 and the 2. Here's what those properties actually look like algebraically. A plus B plus C. We can group the A and the B, or we can group the B and the C. It makes no difference to us. With multiplication, we can group the A and the B, or we can group the B and the C. It does not affect the problem because multiplication is associative. One way that we can use that associative property is when we're trying to simplify expressions. So for example, here we have y plus 5 plus 6. The y and the 5 are grouped together, and I can't combine the y and the 5. They're just not enough alike. But if I reassociate and group the 5 and the 6, I can combine those into 11. Notice what I end with is simpler than what I started with. I simplified the expression. The same thing here. The 5 and the z are not enough alike to combine, but if we reassociate the 4 with the 5 and multiply those to get 20, then we end with a simpler expression than what we started with. Two other properties that are important, but that we're going to sort of brush over, are the identity and the inverse properties. The identity property means that if we add 0, which is called the additive identity, 0 is the additive identity. If we add 0 to any number, it just stays the same, right? This is sort of intuitive. The multiplicative identity is 1, and so if I multiply any number by 1, I just get the same number out. Now, the inverse property is something that we are going to use pretty heavily once we get to solving equations. And the inverse property says that for any number, we should be able to find a number so that when we add, we get 0, right? We're trying to end up at a 0 value. Every integer, I should say, every real number has an additive inverse. That means we can add the negative of that number, and we should get 0. 5 plus negative 5 gives you 0. 3 plus negative 3 gives you 0. Negative 12 plus positive 12 gives you 0. There's also an inverse property of multiplication, and every number except for 0 has a multiplicative inverse, and that's just the fraction version of that number, or 1 over that number. So for example, 5 times 1/5 gives me 1, because I'm trying to get back here to the multiplicative identity. Just like here we were trying to get to the additive identity. 7 times 1/7, or I could reverse that and say 1/8 times 8. These all equal 1. These are inverse. These are the multiplicative inverses of these numbers. Here are some other examples of that. We don't have to dwell on this because we will circle back and talk about these two properties specifically later. All right, the final and probably the most important for today is the distributive property of multiplication over addition. And what it says is that if we have addition inside a parentheses and multiplication to that parentheses, for example, I'm multiplying 6 times a parentheses with addition inside it, right? Then what we can do is we can do what we have been doing and use PEMDAS and add those two items and get 5. Then multiply the 6 by the parentheses and get 30. Check, that works. Everything that we've been talking about still works. If the two numbers inside are not able to combine, though, we may have to use the distributive property, right? So if those weren't 2 and 3, but instead they were 2 and x, and we can't combine the 2 and the x, we would have to use the distributive property. What the distributive property says is that I can actually distribute the multiplication into the parentheses. It has to go to every item, every term in the parentheses. Terms are things separated by pluses, minuses. So if I had 3 items in there, the 6 would have to go to all 3. If I had 5 items, the 6 would have to go to all 5. Let's think about this exact example. We used PEMDAS. We added the 2 and 3. We got 5. We ended up with 30. 6 times 2 plus 3 equals 30. Now let's look at it a different way. 6 times 2 plus 3. If instead we distributed, we would get 6 times 2 plus 6 times 3, 6 times 2, 6 times 3. That's the same thing as 12 plus 18, which still gives us 30. So using the distributive property, this is sort of trying to prove to us that it does work, right? Here are some examples. So on this example, we cannot add these things. PEMDAS won't let us add those. They're just not enough alike. So what we'll have to do is distribute the 5 in. So 5 times y is 5y. 5 times negative 7 is negative 35. Remember I said that we can distribute over addition. You could distribute over subtraction as well, because technically this is the same thing as 5 or y plus negative 7. Y minus 7 and y plus negative 7 is the same thing. We do have to be careful that we're multiplying the 5 by the negative 7, right? So that sign stays with it. The second example, apply the distributive property. I'm multiplying the 2 in. I have 1, 2, 3 terms. So I have to multiply the 2 to all 3 terms. 2 times a is 2a. 2 times 6 is 12b. 2 times 7 is 14. Notice the b stayed with that middle term. The a stayed with the first term. The last term is just a number. Here are a couple examples for you to try. I'll do my normal 3-second rule. Take a second, try this. Pause if you need to. The first one should turn out to be this. The second should turn out to be, before I actually uncover it, we're distributing a negative. And we can actually call that a negative 1, right? We're distributing really a negative 1 to everything. If it's just a negative out there, we can call it a negative 1 if we need to. All right, this is how that simplifies. Negative times negative makes a positive, negative times a positive makes a negative. And that final one, we're distributing a negative 6 to everything. Negative 6 times 2, negative 6 times negative 4. This is what you should end up with. It's important that if there is a negative with this, that it goes to everything as well, right? The negative 6, not just 6 to everything, but negative 6 to everything. Now that we have the properties, we can use those properties to simplify expressions. This was an expression that we saw in that last lesson. 2x plus 3y. Expressions have numbers. They have variables. We don't have things with equal signs yet. Those are equations. We'll get to those in the next lesson. Right now we're trying to simplify expressions. That means we start with something and we're trying to end with something that's more simple. Expressions and equations both have terms. I said earlier that those are things separated by pluses and minuses, and when we get to the next lesson, we'll also have things separated by equal signs. Today, with expressions, specifically, they're separated by pluses and minuses. So this first example has 3 terms. We have 1, 2, 3, separated by the pluses and the minuses. You see that? 3 terms. The second example has 1, 2, 3, 4 terms. Each term has coefficients. The coefficient is the number that's in the front, the number that's tacked onto the front. So this has 3 terms, 1, 2, 3. Each term has a coefficient, so the coefficient of this is negative 7. The coefficient of this is just 1. If there's nothing there, it's an understood 1. And the coefficient of a numerical term is the number itself, so negative 100. Notice that the sign does go with it. It's not just a regular 7 as the coefficient. Negative 7 is the coefficient. Here the coefficients are 2, negative 1, positive 1, and negative 80. These are the coefficients. You may want to write down the word coefficient somewhere so that you can remember what it is. The coefficient is the numerical part of any term. When we try and combine things to simplify, we're looking specifically for like terms most of the time. Like terms have the same variables raised to the same power. So these two, for example, are like terms because they both have a b with no exponents. The next two are like terms because they both have a p and a q. The p has a squared, the q has a cubed exponent. So since they have the same variables and the same exponents, they're like terms. And ditto here, they both have just a regular old w. Notice these are not like terms because one has a c and one has a d. They don't have the same variables. These are not like terms because they both have p's and q's, but they have the wrong amounts. One of them has p squared, the other one has p cubed. One of them has q to the third, the other has q squared. They have to have the same variables and exponents. These are not like terms because they don't both have a w. Notice that this does not have to do with the number out front, right? These two are like terms, and it has nothing to do with the coefficient. We were talking about the coefficient on the last slide. What it has to do with only is the variable and its exponent. So because they both have a regular b, they're like terms. We can combine like terms. If we have like terms, we can combine those. To combine like terms, all you're going to do is combine their coefficients. So these two are like terms, right? 7x and 2x, they both just have an x. When you combine them, 7 plus 2 equals 9. And the variable and exponent stays the same when we're combining like terms. It's just a x. Since we started with x's, we're just going to have more or less of those same things, a different amount of the same type of thing. 7 apples and 2 apples makes 9 apples. Notice that all three of these have a p, regular p, not p to the second, p to the third. They all just have a p. So I know my answer is going to have a p in it. Negative 2 plus 3 minus 1 actually ends up being 0p, which is equal to 0. We'll do one more of these together. We have like terms here, and we have like terms here. The yz and yz, we can combine those to make another yz. 3 minus 2 is just 1 yz. You can write the 1 in, and you don't have to if you don't want to. The 1 is understood if you'd like it to be that way. The 5 and the 9 now. 5 plus 9 makes 14. Notice I started with things with yz's, and I started with regular numbers, and I ended up with things with yz's and regular numbers. Try these next two. Both items have a w to the third, so we can combine their coefficients. And then the last one, we have combinations of pq's and combinations of regular numbers, so we should end up with things with pq's and regular numbers. If we try and combine these things, we're still using PEMDAS, right? We're still using PEMDAS from last time. But if we want to combine and simplify this expression, notice that it has some distribution, it looks like, and it has things with numbers, and it has things with variables. So using PEMDAS, can we combine anything inside? It looks like no. So what we'll have to do is distribute. Remember I said when we distribute, we have to distribute the number and the sign, so that negative 2 is going to go to both. I'm going to keep the 5. Negative 2 times 3x would be negative 6x. Negative 2 times 7 would be negative 14. And we're always going to ask ourselves when simplifying if there's one more step that we could do. So look at this. Is there any like terms, any distribution we could do? In fact, there are like terms. There are regular numbers. The negative 6x doesn't have anything it can combine with. 5 minus 14 is negative 9. Look at what we started with and what we ended with, and try and agree with me that what we ended with is more simple than what we started with. We have simplified our expression. All right, another. We've got things in parentheses I can't combine. Things in parentheses I cannot combine because they're not like terms. What I can do is distribute. I'm distributing 1/4 to each of those items. So 1/4 times 4 is 1k. 1/4 times 2, type it in your calculator, do second f-d to change it into a fraction. If you need to, you can go back to the last lesson to review how to do that on your calculator. 1/4 times 2 is 1/2. Negative 1/2 times 6 is negative 3. Okay. And negative 1/2 times 1 is negative 1/2. Now, do we have any like terms that we can combine? I have things with k's. Those add to negative 2k. And I have things with regular numbers, and those just add to 0. And so I can just write this as negative 2k. I don't have to include the 0 in my answer. Try the next one. Pause the video and try it. After distribution, this is what you should look like. I've underlined and swirly braced your like terms to combine. There are a lot of things with s's and a lot of things with t's, so we should end up with things with t's and s's. It doesn't matter the order that you write these things in. You could have had 3t minus 11s. That's perfectly fine. Remember that addition is commutative. In math, algebra, mathematicians typically like to keep variables in alphabetical order, and so that's why I put the s before the t. But again, the 3t minus 11s is also a correct answer. All right, one more, a challenging one here. We've got 7a minus 4 bracket, 3a minus 2 parentheses, a plus 6 close bracket, minus 4. Again, if you need to go back to the last lesson, you can to review some of this stuff, but that bracket in this context acts the same way as a parentheses. And when you have parentheses nested within each other, you're going to start with the innermost. You're going to start on the inside parentheses. So I'm looking at this parentheses first because it's inside the other. Take a second to see if you could do this challenging one. If you need to take the first step, you can. Here's the first step. Oh, that's just rewriting the problem, I'm sorry. Here's the first step. I distributed the 2 into the parentheses. Then you'll look for like terms. Pause at any point to try and keep working. Combine the 3a and the negative 2a to make 1a. Sometimes I like to write in the 1a just to keep up with what I have. You could have written just a, and that's perfectly fine. Next, I'll distribute the negative 4 in. After distributing the negative 4, I'm looking for like terms again. I have things with a's and things with numbers, so I should end up with things with a's and numbers at the end. All right, one more. This is challenging just like the last one. This is the last example for this lesson. Start with the inside parentheses. So we'll distribute the 3, and we'll distribute the 8. Remember, that's a negative 8 that you're distributing. We'll combine like terms within that bracket. So the 6 and the 8, the 6 and the negative 16. Then we'll distribute the negative 6 in. And then once more, we'll look for like terms. And this should be our final answer. Notice that this is much more simple. We're asked to simplify that expression. That's a much more simple way of writing the same expression. They mean the same thing. The bottom one is more simple than the top one. All right, what we're going to do in the next lesson, we're going to move on to equations. We've been talking about expressions and simplifying expressions. We're going to move on to equations, trying to solve equations, and also some word problems. So look forward to that in the next lesson.